Hi students, in this session we are discussing about the most important 50 questions of the lesson chemical reactions and equations. Question number 1. A solution of a substance X is used for whitewashing. See, a substance X is used for whitewashing. From that you have to understand it is calcium oxide. Okay, calcium oxide or common name quicklime. Remember that quicklime is the common name of calcium oxide and calcium oxide is the chemical which is used for whitewashing. That you keep in mind, and that is the answer for the first question. Now second question, write the reaction of the substance X named in question number 1 above with water. So calcium oxide is X. It is reacting with water, right? It is reacting with water. You are getting what? Calcium hydroxide. Calcium hydroxide. Understand, right? So the product is calcium hydroxide. Got it? Okay, so this is the answer. Calcium hydroxide is also known as what? Slacked lime. Slacked lime. Remember that? Calcium oxide, another name is quicklime. Remember, the chemical which is used for whitewashing is calcium oxide. Its common name is quicklime. When it reacts with water, you will get slacked lime. Slacked lime, the actual name is calcium hydroxide. Remember all these points. Okay. And this equation is an example for combination reaction. Here you can see two reactants combined together to form a single product. So this reaction is an example for combination reaction, and during this reaction heat energy is released out. So this reaction is also an example for exothermic reaction. That point also you keep in mind. There are few questions associated with this activity. Remember, this activity is associated with what? With the electrolytic decomposition of water, or we can say electrolysis of water. We know what? The water in the presence of electricity undergo decomposition to give what? Hydrogen and oxygen. Right? This we know. Okay. In this activity, you can see a step. Add a few drops of dilute sulfuric acid to the water. Why we are adding sulfuric acid to the water during electrolysis of water? You can expect a question like that. Why we are adding sulfuric acid to the water during electrolysis of water? And the answer is water is a poor conductor of electricity. Okay, for electrolysis to happen, electricity is supposed to pass through the water, but water is a poor conductor of electricity. So we are supposed to increase the conductivity, right? Okay, then only current can pass through it. Okay, so to increase conductivity of water, we are adding what? We are adding sulfuric acid to the water. Water is a poor conductor of electricity. To increase the conductivity of water, we are adding sulfuric acid to the water. See, conductivity, increasing conductivity is very important because here what we are doing? Electrolysis of water. For that to happen, electricity is supposed to pass through the water, but water is a poor conductor. So to increase the conductivity of water, we add some sulfuric acid or some acid to the water. Hope you understand my point. We can check about the next question. See, here you can see anode, right? And cathode. Remember, anode is positively charged electrode. Remember it. They will ask. Positive charge electrode is anode and negative charge electrode is cathode. Okay, and second question associated with that is which is the gas produced at anode? It is very clear, it is oxygen. So remember, at anode which gas? It is oxygen. And at cathode which gas? In the figure it is very clear, it is hydrogen. Remember that anode is positive and the gas produced at anode is oxygen. Second is what? Cathode is negative and the gas produced at cathode is hydrogen. Very important question. Very important question. Next question regarding the same activity is, why is the amount of gas collected in one of the test tube in activity 1.7 double of the amount collected in the other? Name this gas. Okay, it is very clear. If you check the experiment, it is very clear. See here lesser gas and here more gas, which means the volume of the hydrogen produced is double than that of the oxygen, right? What is the reason? We can check the equation. 2H2O undergo decomposition to give what? 2 hydrogen and 1 oxygen. Water undergo decomposition to give hydrogen and oxygen in what ratio? In 2:1 ratio. 2 hydrogen is produced and 1 oxygen is produced on decomposition of water. Understand? So the volume of the hydrogen produced will be double than that of the oxygen. Hope you understand the point. Okay, so name this gas. Hydrogen, right? Hydrogen, which is collected at cathode, has double the volume as that of oxygen. Reason all of you already understood, right? Water on decomposition, you are getting 2 units of hydrogen and 1 unit of oxygen. Okay, the volume of hydrogen is twice that of oxygen. Hope you understand the answer. If you want, you can copy the answer from here. Okay, next question. Why does the color of copper sulphate solution change when an iron nail is dipped in it? See, copper sulphate is CuSO4. Remember, copper sulphate solution color is blue. Very important point. Keep that point in mind. And what we are doing, we are dipping an iron nail. So Fe. Okay. And remember one important point. Fe is more reactive than copper. Fe is more reactive than copper. So definitely displacement reaction will take place. You will get FeSO4 plus copper. Right? Fe displaces copper from its solution. So what will be the color? What will be the color change? See, copper sulphate solution, I already said is blue color. And iron sulphate color has green color. Okay, green color. So what you can see, what you can observe, the blue color fades and green color appear. As the reaction proceeds, see, copper sulphate is becoming iron sulphate, right? So the blue color gradually fades and you can see the green color is appearing. Green color is appearing due to the formation of FeSO4. Very important question. Next question. A shiny brown colored element or metal. In the question, if they mention like shiny brown color element or metal, you have to understand it is copper. Okay, they won't be saying it is copper. You have to understand from the term shiny brown colored element, or maybe they will be saying metal. In both case, identify it as copper. So X is copper. Now on heating in air. Okay, anything heating in air means reacting with oxygen. That you must know. Okay, so definitely copper react with oxygen. What you will get? You will be getting copper oxide. And after that you can balance it. Okay, becomes black in color. Name the element X, that is copper, and the black colored compound formed, that is copper oxide. Remember, copper oxide is black in color. Remember, copper oxide is black in color and copper is shiny brown colored metal or shiny brown colored element. Okay, remember that points. And you can expect this question. It's a very good question. In the reaction, CuO plus H2, CuO plus H2 gives Cu plus H2O. Here you are supposed to identify the substance which is oxidized, the substance which is reduced, oxidizing agent, reducing agent. Remember one important point. For this type of questions, all your answers come from the reactant side. Okay, don't pick some answers from the product side. All your answers will come from the reactant side. That is very important hint. For this type of questions, all your answers will come from the reactant side. Don't pick your answers from the product side. Okay, now we can check the answers, right? Okay, we can check. The substance which is oxidized. You know what is oxidation, right? Oxidation is addition of oxygen. It is very clear. H2 get oxygen. So H2 undergo oxidation. H2 undergo oxidation. So your answer is 2. Now reduction. CuO, you can see it loses oxygen. Okay, by definition that is reduction. Correct. By definition what is reduction? Either adding of hydrogen or losing of oxygen. Right. Okay, so which one undergo reduction? CuO. Now what is oxidizing agent? It's very easy. Oxidizing agent undergo reduction. Keep that point in mind. Oxidizing agent undergo reduction. So which one undergo reduction? CuO. Okay. Now reducing agent. What is the hint? The reducing agent undergo oxidation. Got it right? So it is H2. Okay. Now you can see all the answers are coming from the reactant side. Okay. Keep that hint in mind. It will help you. Next question. Why should a magnesium ribbon be cleaned before it is burned in air? See, first of all, you must know one point. Magnesium is a highly reactive metal. Sodium, magnesium, potassium, all these are highly reactive metal. That you must know. Now, see, assume we are storing the magnesium ribbon in a bottle. Definitely inside the bottle, oxygen will be there, right? See, this oxygen react with the magnesium metal and magnesium oxide will be formed, and that magnesium oxide will be forming a protective layer around the magnesium. Okay, the molecules on the surface of the magnesium ribbon react with oxygen so that a layer of magnesium oxide will be formed on the surface. It protects magnesium from further reaction. Understand what I am saying? See, we have magnesium ribbon in the bottle. Inside the bottle, definitely oxygen will be there. So the molecules on the surface of the ribbon, right? It will react with oxygen. So a thin layer of magnesium oxide is formed on the surface. Now, see, after this layer is formed, no gas can interact with the magnesium ribbon. Already it is protected. Understand, right? Now, we are taking this magnesium ribbon outside, and what we are going to do? We are going to burn it in air. Burning in air means what? Reacting with oxygen. Okay, reacting with oxygen. Oxygen and magnesium ribbon are not now exposed to each other, right? Because in between there is a thin layer of magnesium oxide. So for the reaction, for burning to happen, first you are supposed to remove this thin layer of magnesium ribbon. That is why you are supposed to clean it. Once you clean it, this thin layer will be removed. Magnesium ribbon will be exposed to oxygen. You can burn it. Understand? We can read the answer, okay? Magnesium is an extremely reactive metal. When you store it, okay, inside the bottle, what happened? It reacts with oxygen to form a layer of magnesium oxide on the surface. Only on the surface, okay? So it is protected. It is not exposed to any gas. Okay, this layer of magnesium oxide is quite stable and prevent further reaction of magnesium with oxygen. Now, we want to burn it, right? Burning means what? Reacting with oxygen. Okay, burning means reacting with oxygen, but this thin layer protect magnesium from burning. So, For burning, first of all, you have to remove that layer. That is why we are cleaning that. Hope you got it right. This question is also very important. Remember this point. What are the characteristics of chemical reaction? Or they will be asking what are the changes we can observe during a chemical reaction. Okay, very important. Evolution of gas can happen. Precipitate can form. There will be a change in color sometimes. There can be a change in temperature or change of state will be there. What are the changes which we can observe during a chemical reaction, or what are the characteristics of a chemical reaction? Remember these points. Okay, these are the changes you can observe during a chemical reaction. Any one of this change will be there during a chemical reaction. Sometimes more than one changes you can see. Evolution of gas, formation of precipitate, change in color, change in temperature, and change in state. Okay. This is an easy question. Match the following question. Okay, we can check. First one, AgNO3 and Na2CrO4 gives Ag2CrO4 and NaNO3. It's very easy exchanging of partners. See, Ag is combining with Cr and Na is combining with NaNO3. Sorry, NO3. Double displacement, right? Because exchanging of partners take place. Second, ammonia decomposing to nitrogen and hydrogen. Single compound or molecule split into simpler molecules, right? Okay, definitely it is decomposition. Okay, second one is decomposition reaction. Third one, see, you can see C2H4 combining with H2O to give a single product. Two or more molecules combine together to form a single product. That is the definition of combination reaction. So it is A. And the last one, Fe2O3 plus 3CO gives 2F2 plus 3CO2. Definitely it will be what? It will be displacement reaction, right? Here it is 2Fe. Okay, 2Fe, not F2. 2Fe plus 3CO2. You can see CO is displacing Fe from its compound. So Fe, you can see it is displaced out. And CO combined with oxygen and you are getting 3CO2. So it is a displacement reaction. Okay. Hope you got the answers right. It's a very easy one. Next question. Which of the following is not a physical change? Okay, for answering that, before that you must remember this point. If only change of state is taking place, no other change is there, only change of state is there, then it is physical change. Okay, if change of state is there along with some other changes, then it can be a chemical change. But if only change of state is there, then it will be what? It will be a physical change. Dissolving, for example, sugar dissolving in water, salt dissolving in water. Dissolving is not a chemical change. Dissolving is a physical change. Remember that. Now, combustion. Combustion means reacting with oxygen. Reacting with oxygen, reacting, right? Chemical reaction. It's a chemical change. Reaction will be there for combustion. Okay. Or burning, combustion, whatever, it is a chemical change. Okay, now we can check the answers. Boiling of water. See, only water becoming water vapor. Only change of state take place. So it's a physical change. Ice, okay, melt to water. Only change of state take place. It's a physical change. Then dissolution of salt in water. Salt is dissolved in water. Sugar is dissolved in water. Whatever things dissolved in a solvent is a physical change. Now next, combustion. I already say combustion means it is a chemical reaction of something with oxygen. It's a chemical reaction. So it is not a physical change. Okay, got it right? This is the answer. This is not a physical change. Okay. Okay, next question. Which of the following is an exothermic process?
First one you already know, reaction of water with quicklime. You already know it is an example for exothermic process and combination reaction. CaO plus H2O gives what? CaOH twice. Along with the product, heat energy is also released out. So it is an example for exothermic reaction, right? The second reaction maybe you don't know, dilution of an acid. When water is added to an acid, we call it as dilution, diluting process. During that process also, huge amount of heat is released out. So it is also an exothermic process. During dilution, dilution means what? Adding water to the acid. During that process also, huge amount of energy will be released out. So it is exothermic. Evaporation of water. Evaporation of water. See, assume for understanding, you can take boiling. Okay, boiling or evaporation. See, when you give, see, for evaporation to take place, heat is supposed to supply, or boiling to take place, heat is supposed to supply. Okay, heat is taken in so that water become water vapor. Okay, for evaporation and boiling, water becomes water vapor. For that, water will absorb heat energy. Absorbing heat energy means endothermic. Sublimation also similar. What is sublimation? A solid substance directly convert to gas, right? During sublimation also remember that substance will absorb heat energy. So for boiling, for evaporation, for sublimation, all these cases heat is taken in. Taken in means endothermic. Okay, but in first two cases, heat energy is released out. So we can consider it as an exothermic process. So answer is A, option A. Next question. Which among the following statements are true? Silver chloride on exposure to sunlight for long duration turns gray due to. You can see some statement. This is the reaction, right? Ag chloride, right? AgCl. It is solid, okay? Becomes Ag, which is solid, plus chlorine. So this is the reaction that you already know. Now, the formation of silver by decomposition of silver chloride, correct, right? Silver chloride undergo decomposition. This is gas, okay? And you are getting what? Silver and chlorine gas. So you will get silver by the decomposition of silver chloride. So the reaction taking place is decomposition. Got it right? Okay. So this is correct. Now sublimation of silver chloride. Sublimation means what? Something converting directly from solid to gas. It is not happening, right? Here it is a chemical reaction, not sublimation. Right? Here you can see AgCl undergo decomposition, not sublimation. Third one, decomposition of chlorine gas. Wrong, right? Decomposition of AgCl is taking place, not decomposition of chlorine gas from silver chloride. Decomposition of silver chloride is taking place so that you are getting silver and chlorine gas. So this is also wrong. Last, oxidation of silver chloride. Wrong, right? It is not oxidation. It is decomposition of silver chloride. So what is the right answer? Only one. The formation of silver by decomposition of silver chloride. Along with silver, chlorine gas is also formed, okay? That also you keep in mind. During this reaction, you remember this point. This is very, very important. White color of the silver chloride. Color of the silver chloride is white. Very important. What happens to that? It changes to gray. Why? Because silver is gray. Okay. From white color AgCl, we are getting gray color silver. That color change also you keep in mind. Very important point. That color change. Some questions will be asking indirectly by referring the color. Okay. So remember this color. AgCl is white color and silver is gray color. Okay. Next question. Which of the following is an endothermic process? So keep this point in your mind. When solid become liquid, that means melting, then liquid become gas, that is boiling, or we can say evaporation, or in the case of sublimation. All these cases it is endothermic. Okay, now just opposite we can take condensation. Condensation means what? Gas or water vapor become water, gas become liquid, like that. Freezing. Okay, freezing, which means liquid becomes solid. In these two cases, it is exothermic. Condensation, freezing, and I can take one more. It is not connected with this thing. Anyhow, dilution of acid. Dilution of acid. That is also what? That is also exothermic. Dilution of acid, condensation, freezing. Exothermic. Melting, boiling, evaporation, and sublimation. These are endothermic. Condensation, freezing, dilution of acid is exothermic. Melting, boiling, evaporation, and sublimation is endothermic. This is very important hint for doing this question. Now check endothermic. Dilution of acid, it is exothermic. Sublimation of dry ice. Sublimation comes under endothermic, right? So it is endothermic. This is endothermic. Now condensation of water vapor, it comes in exothermic condensation. Okay. Now evaporation comes in endothermic. Okay, so 2 and 4. D is the right option. Sublimation and evaporation, okay, is endothermic, and condensation and dilution of acid is exothermic. So D is the right option. See, next question is, which of the following gases can be used for storage of fresh sample of an oil for a long time? Okay, for this type of questions, always remember the preferred gases are nitrogen and helium. These two gases are inert gases. Okay, they show less tendency to react with fat, oil, or even with other gases. Okay, so these two gases are preferred for storing food, oil, whatever it is. Okay, so answer is helium or nitrogen. Remember that point in mind. Oh, okay, next question. The following reaction is used for the preparation of oxygen gas in the laboratory. And they have given an equation, 2KClO3. In the presence of a catalyst, we are supplying heat and you are getting 2KCl and 3O2. Okay, above arrow mark, if heat is there, which means it is endothermic. Remember that. On above the arrow mark, if you see heat or if you see delta sign, both represent that particular reaction is endothermic. Now check the reaction. You can see a single reactant undergo reaction. You are getting two or more product. Obviously it is a decomposition reaction, and I already say if on above arrow mark heat is there, or if they are showing this delta sign, it is endothermic. So it is a decomposition reaction and also endothermic in nature. It is not combination reaction. Okay, no release of heat, not exothermic. Okay, so option A is correct. What happens when a piece of zinc metal is added to copper sulphate solution, aluminium metal in dilute hydrochloric acid, silver metal in copper sulphate solution? For answering this, you must have a rough idea about this order. Try to by heart it. Okay, see potassium on top, then sodium, then calcium, magnesium, and at the end you can see silver and gold. Okay, and as we move down, the reactivity decreases. The reactivity of the metal decreases. And what is the basic idea of displacement reaction? a high reactive metal displays a low reactive metal from its compound. We can check. First one, zinc. Okay, zinc metal is added to copper sulphate solution. So this is the reaction, right? Now check which is more reactive, zinc or copper. See, on the top one will be reactive, so zinc. So definitely a high reactive metal can displace a low reactive metal from its compound. So you will be getting an answer like this. Got it, right? Now check the second one. Aluminium metal. Aluminium metal means aluminium plus dilute hydrochloric acid HCl. Now check who is on the top. Aluminium hydrogen. On the top you can see aluminium, right? So it undergo reaction. You will get what? AlCl3 plus H2. You can balance it. That you can do by yourself. This is the basic reaction. Okay. You can balance it later, but this is how the reaction will take place. Aluminium plus HCl gives AlCl3 plus H2. Okay. Now we can check the last one. Silver metal. Silver is what? Ag. Is added to copper sulphate solution. Now check who is on the top. Copper or Ag. Copper is on the top, right? Which means Ag is less reactive. A less reactive metal cannot displace a high reactive metal from its compound. Not possible. Ag comes below copper. So no reaction. Okay, for doing this question, better you by heart this. It will help you a lot for answering this type of questions. Okay, next question. A silver article generally turns black when kept in the open for a few days. The article, when rubbed with toothpaste, again starts shining. Why do silver articles turn black when kept in the open for a few days? Name the phenomenon involved, name the black substance formed, and give its chemical formula. This is the question, right? Okay, see here silver article, right? Which means Ag. Now, if it is exposed to atmosphere, what happens is it will react with hydrogen sulfide gas from the atmosphere. Okay, so that you will get silver sulfide Ag2S plus hydrogen. For doing this question, you must know this reaction. Now you check. A silver article generally turns black. This is black in color. Remember that. Silver sulfide is black in color. Okay, so a silver turns black. So you have to understand what? Silver becomes silver sulfide. How? When it is exposed to air. Air contains this gas, right? H2S. Okay, so a metal, okay, is reacting with the atmospheric gases and undergoing the reaction is known as corrosion. Corrosion, you remember, right? Corrosion of iron is what? Rusting of iron. Similarly, corrosion of silver, we normally call it as tarnishing of silver. Tarnishing, or you can simply say corrosion. Okay, anyhow, the black color substance is what? Silver sulfide, color is black. Okay, remember that point, and this is the reaction. Okay, why it happens? Ag, when exposed to air, hydrogen sulfide from the atmosphere react with silver and Ag2S is formed. This Ag2S is what? Black in color. Hydrogen is the byproduct. Okay, hydrogen is the byproduct. Next is an easy direct question. Why do we store silver chloride in dark colored bottles? We know silver chloride, if it is exposed to sunlight, what will happen? It definitely undergo decomposition reaction and you get what? Ag and Cl2. Which means if AgCl is exposed to sunlight, it undergo reaction. So to prevent the reaction, okay, to prevent the photolytic decomposition reaction, silver chloride is stored in dark colored bottles. Got it right? Silver chloride, if it is exposed to sunlight, it undergo decomposition. To prevent the decomposition, we will store the silver chloride in dark color bottles so that the exposure to sunlight can be prevented. Hope you got the answer. Easy one, right? Barium chloride, on reacting with ammonium sulphate, forms barium sulphate and ammonium chloride. So barium chloride, BaCl2 plus ammonium sulphate. Okay, and what is forming? Barium sulphate, right? BaSO4 plus ammonium chloride. If you don't know how to write formulas from the names, okay, you can either message me or give me a comment below the video. Okay, we will be doing a separate video for that. Okay, BaCl2, NH4 twice SO4, BaSO4 and NH4Cl, right? Now, here you can see barium is combining with SO4 and NH4 is combining with Cl. So you are getting this product. That means exchanging the partners. So double displacement reaction. Plus BaSO4, you already know it is a precipitate. It is already in the textbook, right? It is a textbook reaction. One of the textbook reaction, BaSO4 is coming as a precipitate. We know it. BaSO4 is a precipitate. So precipitate is forming, so precipitation reaction. Exchange of partners are taking place, so double displacement reaction. Okay, option D is the right answer. Why do we apply paint on iron article? It's a simple question, in-text question, right? See, metals, for example iron, if it is exposed to air or oxygen, it undergo corrosion. So how to prevent corrosion? To prevent corrosion, what you are supposed to do? We are supposed to reduce the exposure of the metal with air. How can we do that? By painting it or by oiling it. Any method you can use. Okay, our intention is what? To prevent or to reduce the exposure of the metal with air. So you can paint it. If you paint it, lesser exposure, lesser corrosion. Read the answer, you will understand. Oil and fat containing food items are flushed with nitrogen. Why? See, if food items which contain oil and fat are interacting with the oxygen, the food particles become rancid, right? So what we will do when we pack food, right? When we pack food, the packets are filled with nitrogen instead of oxygen. Nitrogen is an inert gas. It does not interact with the food particles. So food particles does not become rancid. Okay, so instead of oxygen, we can fill food packets with nitrogen so that food will be safe for a long period. Understood, right? Next question. Why is respiration considered as an exothermic reaction? First of all, understand respiration and breathing is different, okay? When we breathe, oxygen will reach the lungs and from there it combines with the blood, right? Through blood it reaches the cells, right? And we are eating food, right? The food we eat reaches the stomach. From there, see the glucose. After digestion, the glucose will mix up with the blood and that glucose also reaches a cell, correct? Now, see this glucose and oxygen undergo reaction at cells so that energy is released out. Okay, and that energy is used for our metabolic activities. Glucose and oxygen combine in our cells so that you are getting carbon dioxide, water, which will be eliminated from our body through urine, sweat and by breathing. And see, the byproduct is energy, which will be utilized for our metabolic activity. Remember the point, energy is released out during respiration. Respiration means this combination of glucose and oxygen on the cells, so that energy is releasing out. That is respiration. And during respiration, what is released out? Energy. So it is exothermic. Energy is released out, so it is exothermic. Got it right? What happens when an aqueous solution of sodium sulphate react with an aqueous solution of barium chloride? So sodium sulphate Na2SO4 plus aqueous solution of barium chloride BaCl2. Definitely they undergo double displacement reaction and you will get BaSO4 plus NaCl. You can balance that. Remember, barium sulphate is a white precipitate, that you know, right? If it's a hint, okay, if BaSO4 is present, then you can simply say it is a precipitation reaction or it is a double displacement reaction. Exchanging of partners taking place. Okay, so double displacement, precipitate is formed, so precipitation reaction. Got it right? So this is the answer. Na2SO4 is in the aqueous form, BaCl2 in the aqueous form, BaSO4 is solid, it is a precipitate, white precipitate, NaCl is in the aqueous form. Okay, so double displacement reaction, precipitation reaction, BaSO4 is white precipitate. And remember, this is aqueous, solid and aqueous. Learn it. Okay, it is very important. Learn all the reactions, equations from the textbook properly. Balanced equation you have to learn. Next question is based on a equation on the textbook. What is observed when a solution of potassium iodide is added to a solution of lead nitrate taken in a test tube? So potassium iodide is what? Ki is added to lead nitrate, that is PbNO3 twice. What is happening? We can check. Okay, and we will get KNO3 aqueous, PbI2 solid. So here Ki and PbNO3 twice undergo reaction to give potassium nitrate and lead iodide. Lead iodide is a precipitate. Remember, lead iodide color is yellow. Lead iodide color is yellow. Okay, it is precipitation reaction because precipitation is formed. And you know, most of the or generally we can say precipitation reactions are also double displacement reaction. So this is double displacement reaction and also precipitate reaction. PbI2 is yellow color, PbI2 is yellow color. Okay, and this is the balanced equation. Okay, and remember, you are supposed to learn all the equations from the textbook. That is compulsory. All the activities you have to go through. This reaction is a textbook reaction, is an example for thermal decomposition reaction, very important. Okay, you by heart this equation, by heart the equation including the color, okay, including the color. Maybe they will be saying a green color crystal or a green color X on heating gives a reddish brown substance Y and a gas of burning sulfur, something like that. So green color substance you have to identify as what? Ferrous sulfate. And reddish brown color oxide is Fe2O3. So this question is, this equation is very important. By heart this equation including the color. Okay, including even the state. Solid, solid and gas. Learn this equation, very important. There are a lot of basic questions that you must go through. Define combination reaction, example of that. Define decomposition reaction, example of that. There are 3 types of decomposition reaction: thermal decomposition reaction, electrolytic decomposition reaction, photolytic decomposition reaction, or we can say light decomposition reaction. Definition and example for each. Okay, then we have displacement reaction, double displacement reaction we have. Then definition of precipitation is there, define oxidation, define reduction, define redox reaction, define corrosion, define rancidity. Okay, if examples of these reactions are mentioned in the textbook, you must learn that. That is very important for getting full marks. Okay, now see such a question. Define rancidity and how can we prevent rancidity. Definition you already know, right? Okay, and how to prevent rancidity. These are basic questions. Always give huge preference, very high preferences for textual basic questions. 70 to 80% of the questions will be coming directly. Okay, don't lose mark from basic questions. Similarly, corrosion. Okay, corrosion is defined as a process where metals deteriorate as a result of chemical reaction with air, moisture, acid, whatever it is. Okay, and corrosion of iron is known as rusting. Corrosion of iron is known as rusting. Okay, see, here you can see iron in the presence of moisture react with oxygen. You are getting what? Hydrated iron oxide. And hydrated iron oxide is known as rust. So remember that point. Rust is hydrated iron oxide. Rust is hydrated iron oxide. Very important. Okay, and how to prevent corrosion, that you must know. You can paint the metal. You can use oil or grease. You can use, or you can use the method galvanization. Very important. What is galvanization? Galvanization is the coating of the metal which is supposed to be protected by a highly reactive metal like zinc, and that process is known as galvanization. See, galvanization is the process of protecting a metal by coating it with a highly reactive metal like zinc. Remember that definition. Okay, galvanization is the process of protecting a metal by coating it with a high reactive metal like zinc. You mentioned zinc, that is important for galvanization. Highly reactive metal like zinc. So these are the basic techniques to prevent corrosion. Okay, and definition of corrosion, and hydrated iron oxide is known as rust. Remember these points, important. Okay, next question is, what is balanced chemical equation? Why should chemical equation be balanced? Okay, see, for understanding that, we can check two equations. See, first equation, on LHS part 2 hydrogen, on RHS part 2 hydrogen, on LHS part only 2 oxygen, and on RHS part only 1 oxygen, which means the number of atoms on both sides of the equation is not same. Then it is unbalanced equation. Unbalanced equation. Now check the second one. See here, 4 hydrogen atom on LHS, 4 hydrogen atom on RHS, 2 oxygen atom on LHS, and 2 oxygen atom on RHS. So this is balanced, which means if the number of atoms on both sides of the equation is same, then such a chemical equation is known as balanced chemical equation. You can learn the definition. Now, why should chemical equation be balanced? See, what is the answer? See, for any process which take place in the universe must follow principle of conservation of mass, which means mass can neither be created nor destroyed, which means mass of the reactant side must be equal to mass of the product side. For that, definitely the number of atoms on the reactant side must be equal to number of atoms on the product side. If the atoms are different, mass will be also different. If mass is different, then it is against the principle of conservation of energy. Principle of conservation of mass. Got it right? Principle of conservation of mass, not energy. Got it right? Okay. See, one important thing is there. See, in this session I didn't include balancing the chemical equation section. Okay, we can do a separate video on that. see, you must learn how to balance chemical equation. That is compulsory, because definitely 1 or 2 questions will be there regarding what? Regarding balancing the chemical equations. So learn balancing the chemical equation, learn all the basic activities mentioned in the textbook, learn this 50 questions, you will get full marks. Okay, all the best for your exam.